Welcome to aminacademy.com. In theory of equations, let us discuss about remainder and factor theorems. The remainder theorem states that when a polynomial p of x is divided by the factor x minus a, the remainder is p of a. The factor theorem is a special case of the remainder theorem. It states that x minus a is a factor, then p of x if and only if p of a equal to 0. Here are some details about remainder theorem. Look at this. If a polynomial p of x is divided by the binomial x minus a, then remainder is p of a. The polynomial p of x is divided by a linear binomial x minus a, the remainder is equal to p of a. For example, if you divide the polynomial p of x equal x square plus 2x plus 1, it's a quadratic polynomial divided by x minus a, what will happen? Just here x minus a, that x minus 1 gives the opposite 1, x equal to 1, that substitute x as 1 here, that is p of 1 equal 1 square plus 2 into 1 plus 1 equal to 4. That means remainder is a 4. Without actual division, we are finding. The remainder theorem allows you to find the remainder of a polynomial with division without actually not necessary to do the division. By performing the without performing the division, we can find simply evaluating the polynomial at x equal to a. Now let us factor theorem. Factor theorem, if x minus a is a factor of f of x, then if f of x equal to 0. The statement, if x minus a is a factor of a polynomial p of x, then p of a equal to 0. And conversely, if p of a equal 0, then x minus 1 is a factor of p of x. For example, the quadratic function p of x equal to x squared minus 1, and we put the value of 1 in this, p of 1 equal 1 squared minus 1 equals 0. If equal 0, remainder is 0, then you can say x minus 1 is a factor of p of x. Application, factor theorem helps determine if a linear binomial is a factor of a given polynomial. If p of a equals 0 and x minus a is a factor, we can find. Relationship between two theorems. The factor theorem is a special case of remainder theorem where the remainder is 0. If the remainder when p of x is divided by x minus a is 0, then p of a equals 0 and x minus a is a factor, vice versa. Now let us do some small example. Look at here. If p of x equal x44 minus 3x square minus x minus 6 is divisible by factor x plus 3. If factor x plus 3, that is this p of x divisible by x plus 3, then find remainder, which means without actual division. That is, like first p of x equal x44 minus 3x squared minus x minus 6. Here x plus 3 is a factor, so we have to put p of minus 1, that is x is minus 1 we have to put, which is equal minus 3 into 1 square minus 1 minus 6. Here minus 1 power even power is 1, positive 1. Here square, that is also even power 1, that is 3 into minus 3 into 1 is minus 3. Here minus 1 into minus 1 is plus 1 minus 6, which is equal, positives are 1 plus 2 is 1 plus 1 is 2, then negative is minus 9, that is minus 9 plus 2 equal to minus 7. Therefore, remainder is minus 7. one more question. Without actual division, show that (18) x power 10, that is p of x, we can write it, plus 19 x power 5 plus 1 is divisible by x plus 1. How to do this one? Here here x plus 1 is given, therefore we have to use it, p of x minus 1. So 18 minus 1 power 10, 19 minus 1 power 5 plus 1. Here minus 1 power, positive power is, even power is positive. So here 1 in minus 1 power 10 is 1, that is 18 and 20 is 18. Here odd power of minus 1 is odd, so minus 19 plus 1, which is equal 0, because 18 plus 1 is 19, minus 19 is 0. Therefore, we can say p of minus 1 equal to 0, then you can say x plus 1 is a factor of p of x. So far we discussed about, simply explained about remainder and factor theorem of polynomials. If you have done, please subscribe our YouTube channel.